Alright, so we'll start with UDP and then move on to everything about TCP. So what is the difference between the two? First of all, TCP provides everything that you will ever need and UDP provides nothing, almost. So this is what we call this is basically unreliable, this is reliable. Because it is reliable, every packet is numbered. Here the packet doesn't have to be numbered, although you could put numbers. Every packet is add, nothing is add. Last packet is retransmitted, nothing is retransmitted. Because everything is retransmitted, it may cause a long delay. Here there is no delay, everything just gets there. So if you want to send 1,000 packets, just send 1,000 packets, done. Alright, quick and lossy. Correction oriented service. Before you can send the first packet, you have to send the message which is called connection. Please, I want to talk to you. Then you say, yes, okay, I can talk to you, but please send me no more than 3 packets at a time. So all that is negotiated before we can start the first packet. Here there is no connection. You can just send 1,000 packets. Unannounced, connectionless service. Good for reliable and delay insensitive protocol. So this is good when you need the reliability. This is good when you need the delay sensitivity. You want to get things done fast and on time. This is applications like email, HTTP, FTP, remote terminal access. This is applications like telephony, streaming, multimedia. Okay? So what does UDP do? Well, all it does is multiplexing. It does provide multiplexing. I said it doesn't provide anything, but it does provide multiplexing. Multiple people can be talking to a server using UDP. So they have the port numbers. Same port numbers are used for TCP and UDP. So there is source port, destination port. Then the other 2 fields are length and checksum. That's it. Well, and these are the sizes of these fields: 16-bit port number, 16-bit port number, 16-bit length, 16-bit checksum. So it is connectionless, no flow control, no error recovery, no acknowledgement, and provides multiplexing by port numbers. So you could use different ports. Checksum is optional. So this checksum is optional, and it applies to pseudo header, same as TCP and UDP segment. If not used, it is set to 0. If the checksum is 0, means it is not being used. And this protocol, UDP, is used by network management, DNS, multimedia, that are last order and delay sensitive. So we already talked about multimedia, but why for DNS and why for network management? Well, let's say you want to make a query to DNS and ask what is the IP address for www.google.com. Now you could set up a TCP connection. Then you could say, well, okay, can I talk and this and that, and then you say, well, I have only one simple question: what is the address for www.google.com? And it could send you the answer, and then say, okay, now close the connection. So when you have this query response, only one query, one response, then we prefer not to do the connection. Alright, we just send a packet request, the response comes back. If the response times out, we send another request. Same thing for management. Management command is like to the router, how many packets have you dropped, or how many packets have you forwarded? That kind of request can be sent to the router, and the router can respond to that request. And if it doesn't make it, you send it again. Alright, so rather than have the transport provide the reliability, you just provide it in the application if you need it. Many applications don't need it. For example, multimedia doesn't need it. Multimedia, if you send some voice, if it didn't make it, blip. You just play a blip and move on. Actually, they don't play a blip. I mean, when we come to multimedia, what they do is they replay the previous sound. So when sometimes you listen to my lectures online, everything is recorded, right? There's a lecture online, and if a packet is lost, you will hear the same thing again and again. Like it might say 2, because the packet 2 was the last one that made it, and then 2 or 3 packets didn't make it. So it just plays the same sound again. Now this is, I think, okay, this is because I haven't verified this, but there are two connections there. One is a control connection and one is a data connection, just like FTP. The control connection, uncontrolled connection, you send a command like restart, go back, cancel, rewind. Those commands are go on the control connection. Those are very reliable. Those have to be sent reliable. So if you want to rewind, you just send a rewind command, and that goes with TCP connection. All right. In parallel, the data is coming on the UDP connection. Actually, it's not a connection, but if you want to call it a connection, so it comes on the data path. All right. So when your command gets lost, then it doesn't have any choice but to wait. So that's why I said I think. Now the thing is, the data packets, now every streaming application will do buffering. Every streaming application does buffering. Now if UDP uses TCP for data connection, that is their decision. And so, I mean, that way just don't want to miss anything. But it would be many applications. I could think of another application where I would use UDP for data. So the question is, would you ever want to emulate some part of TCP and UDP? The answer is that's what exactly is done. So if you want any reliability, some applications want some limited reliability. In which case, maybe they want to just retransmit once, and if it doesn't succeed, done. I don't want to do second retransmit. Suppose you have an application where you want to retry at least once, but not more than one. TCP will keep retrying until that is done, right? So they will do it in the application layer. You can do all of this, what we talked about in the transport layer, could be done in the application. The application could do the sequence numbers, it could put the retransmission, it could have a timeout, everything. Except that since so many applications needed all this stuff, they said let's just do it in one layer called TCP. So yes, you can do, whenever the UDP is used, a lot of things do go into the application.